Look at how to work out this problem, and let's see how it goes. So saying here we have a diagram that shows the model of a crane with a counterbalance weighing 200 newtons. This counterbalance can be moved further or closer to zero to accommodate different loads. What is the maximum load the crane can lift? So here, where is the zero? The zero here is going to be taken to be here, this mark here. So this is going to be where our pivot is going to be. The distances are measured from here going this side and from here going this side. So depending on what we want. The other thing that we just want to be careful of here is the question says the counterbalance weighing 200 newtons. Then when you check on the diagram, the label for the counterbalance is this side where you have a weight of 800 newtons, and the label for the load is this side, and the load is the one with the 200 newtons. Regardless of how you take it in this case, you're still going to get the same answer, but for this calculation, we're just going to work it out taking the counterbalance to be 800 newtons so that we stick with what the diagram is showing. But even if you had still gone this side and say the counterbalance is 200, you see that you still get the same answer as what we're going to get here for this problem, of course. Okay, so how does it work? So when it comes to a crane, what would happen is that you have a weight that is this side, and then the weight is used to support whatever we are trying to lift the other side. So if we're trying to lift something that is very small, what they would do is the counterbalance is going to be shifted closer to the pivot so that we reduce the distance from the pivot to where the counterbalance is. We know to say moment is force times distance. So when the distance is small this side, for the same counterbalance of 800 newtons, a small distance implies that the moment is going to be smaller. Yet the load the other side will still be at a further distance from the pivot, meaning even though the force is small for the load, when you multiply it with that big distance, the product might still be able to balance up the clockwise moment which was caused by the counterbalance, so that the system eventually remains in equilibrium. But if the load that is to be supported this side was to be bigger, what would happen is that now to be supported, the counterbalance would have to be moved further from the pivot, increasing the distance from the pivot to where the counterbalance is. So that the product for the moment will be slightly more. Yet the other side to where the load is, the distance will be the same. But because now what you're trying to support has a greater weight, the moment will be bigger. So by adjusting where the counterbalance is, we can ensure that we can support greater loads that are the other side. So this is the mechanism of a simplified version, of course, of the crane that they have presented here. So all in all, we have the weight. So the weight, you see the counterbalance, if this is our pivot, the counterbalance is causing a clockwise rotation about that pivot. And the load this side is causing an anti-clockwise rotation about the same point. So if you look at the clockwise rotation caused by the counterbalance, it will be this, multiplying the distance to the pivot or from the pivot. This has to be equal to the anti-clockwise rotation, and the anti-clockwise is caused by the load. So take F2 to be our load, multiplying the distance from the pivot to the load. When you look at this setup, the distance from the pivot to the load is from here to there. So the distance from the pivot to the load is 2 meters. So here we have 2 meters. Then next up, for us, the maximum that this crane can support occurs when the load or when the counterbalance is at its furthest point. So at this point, it can support something that is very heavy. And as it gets closer, what it can support is slightly lighter. So if you wanted to support something that is heavier, as you saw earlier, you have to move the counterbalance further away. So it will support its maximum load when it is at its furthest point, and that is 1 meter from the pivot. So it supports its maximum load when it is 1 meter away from the pivot. And since here we are solving this for maximum load that it can support, the distance we're going to use will be its maximum displacement of 1 meter. And the counter load that we are dealing with, again, I want to use that 200 newtons. We'll use the one on the diagram. We'll go with 800 newtons here. So we want to find what load can it support? What is the maximum load? See, the load that will come out this side, that has to be the maximum it can support, because at this point, whatever the load here is, that is what will ensure equilibrium here. So we want to find out what F2 here must be, so that when you multiply this compared to this, you get the same thing. So in the end, you have 800 is equals to, this side you have 2F2, divide both sides by 2, so over 2 this side, over 2, you have 2 into 8 goes 4 times, so that F2 will be equals to 400 newtons. So here we see that the maximum load that this crane can support is actually 400 newtons. Now you notice that even if you were to say, okay, let me follow what the question is saying, the balancing, the counterbalance balance weighing 200 newtons, what would you get in this case? So in that case, how would you have worked out the problem? You see, if you took the counterbalance to be the 200 newtons, now for maximum support, it has to be at its maximum displacement, meaning furthest from the pivot, which is exactly where it is. The force counterbalance 200, furthest point, that is at 2, equals to the maximum it can support, which is you're not going to use the force here. You're trying to find what it can support, the maximum it can support. Don't just get the 800 because that's what you're seeing there. So we're trying to find what this is, and this, of course, at what distance here. We know to say it also has to be at its furthest point, so that is going to be at 1 there. When you multiply, you get 400 here, you get F2 here. You see that still here you get 400 newtons. Okay, so making the correct answer here as B.